Okay, so very good evening to all of you. So Sri, Madhumita, Shobna, Soumya, Priyanka, good evening. Okay, so we will start our session. So in our last class, the concept of array that was going on. So one dimensional array, we have studied how to declare an one dimensional array, how to initialize, how to initialize an array. So that part we had discussed. So today, so two program basically I will discuss very popular program. Objective is one, that is searching. Searching. Searching is an operation. Searching. So already I have told an array is a data structure. Data structure means it stores data and some operation we can perform. So searching is an operation. Sorting is an operation. Searching, to search a specific data item. That means an array is given and a data item is given. Suppose an array is given. Let it. So this is an array. Let this is an array. Let this array containing some data items. An array containing some data items. Let it 25, 10, 35, 40, 60, 55, let it 70. So let my array name is suppose ARR and zeroth index, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index. So we know that once we declare an array, so index is generating. So in this way, let it we have an array containing some data items. So here there are 7 data items. Index is 0 to 6. And suppose a specific data item we have to search. Suppose let it that data item is 60. Suppose. So the data item 60 we have to search. We have to search means the index value of 60 we have to find out. So the index value is 4. So we will write a Java program, and when we will run that program, we will get the output that is 4. So 60, the data item 60 is present in which position? In which position means in which index value the data item 60 is present. So that is 4. So there are two types of searching technique. One is linear search. One is linear search and one is binary search. So very popular techniques, linear search and binary search. So these 2 points actually coming under a data structure. For the interview point of view, this is also important. So first of all, we will know the concept of linear search. So linear search means linearly we will search. First zeroth index data item we will see. So 60 equals to 25 in zeroth index. So if condition is true, then output will be 0. Zeroth index is the output. If false, then linearly, then I will go to one index. In one index, I will search the data item 60 is present or not. In one index 10 is present. So 60 double equals to 10 false. Then I will go to in two index. In a two index, I will see whether the data item 60 is present or not. Here also 60 is not present. Then I will go to next index data item, that is 3 index data item. 3 index data item is 40. So 60 is not here also. Then I will go to next data item. In 4 index, I saw the data item 60 is present. So hence the output is 4. Index value is 4. That means what I did, linearly I searched linearly. First zeroth index, then one index, then two index. So this is called as traversing. I visited. Okay, so linearly I searched, then I found in 4 index the data item 60 is present. So hence the output is 4. So if the data item is not present in any index, then data item not available. Then we will define a method. So if the data item I will not get, then one line that I can write return -1. Okay, so first of all, this is my concept. Then we will go to for how to write the code. So first of all, I will go to my environment. Let class name, suppose class linear source. Let my file name is linear search.java. Okay, suppose I will define a method, and in that method or definition, I will write my business logic. Then that method I will call, because we know in programming when a method is calling, then method definition will execute. So a method definition, it will represent a task. My task is to search a specific data item to find out the index value of a specific data item. So for this, I will define a method. Let my return type is int because little bit analysis I am doing. If I will get my data item, then I will write one return statement because index value is an int value 0, 1, 2, 3. So return type I took int. Then one method I will define. Let my method name is search. Then within parentheses, how many parameter, how many argument I will take. So you remember number of input. We will do little bit analysis. Definitely an array is given. An array is given. So this is my input. Then once an array is given, I will find the length of the array because linearly I will search. So definitely for that I will use a loop. So the length of an array we will require to find. So for this, for getting the length of an array, I will take let a variable n. Then a data item is given. Which item I will search? Very important. Mindfully listen and you watch. So in this way, one method I am defining. One method I am defining. Okay. So now I will write my logic. If the method, so I will preceded by the keyword static, then also we will get a little bit benefit because static method, if we are defining, no need for declaring an object to call this method. Static method is a class level concept. Okay, so very simple logic is very simple. So within parentheses, what I took an array, the variable n I have taken for length of an array, that is arr dot length, and item, the variable item I have taken. So that one item is given means which data item is given. So that data item we have to search. So one for loop I will use because linearly from 0th index onwards I will search. So I can write for int I equals to 0. I is less than n, I plus plus. I will find n. N is the what? RL length. I will represent explicitly. So very simple. Linearly, I will search if ARR of I double equals to item. Logic. Very simple. Return I. So if ARR of I, first of all, I is 0, ARR of 0 double equals to item, let item is 60. So ARR of 0 is 25. So 25 double equals to 60, false. So when the condition will be true, then return I, that I value. Then I plus plus I is equal to 1. Then I is equal to I is less than n. So here length is 7, number of data items 1, 2, 3, 4, 5, 6, 7. So I equals to 0, 0 is less than 7, condition is true. Then this is the for loop body. For loop body is an if expression. If ARR of 0, ARR of 0, that is 25. 25 double equals to item, item is 60. 25 double equals to 60, that is false. So if false, then return I. This is the if statement. Return I, this statement will not execute. Then I plus plus, that is 1. Again, 1 is less than 7. Again, condition true. Then it will check ARR of 1 double equals to item. Item is 60. ARR of 1 is 10. So 10 double equals to 60. It is false. 35 double equals 60. False. 40 double equals to 60. False. 60 double equals to 60. So when the value of I is 4, so 60 double equals to 60. This is true. So return I. So when 60 double equals 60 is true, return I. That means return 4. So apart for loop, suppose if data item not present in array, then I can write suppose return -1. Okay. So now I will take in a main method, I will take that array. So whatever the array data item 25, 10, 35, 25, 10, 35, 40, 60, 40, 60, 55, 70. So one array I took, then we have taken n. So explicitly I will represent this is the length. So array length, this part already we have known. Then data item int item equals to 60. Okay. So now that method I will call. Method name is search. So I will call. So ARR is my array. N I have taken for length. Then item. So this is the method call. So let it output. I will store in a or I will assign in a variable. Let output variable is index. Okay. So now I can write. So if so index double equals to -1, that means data item not present. So I can write the output statement system.out.println. So simply I will write the data item not present in array. Okay, otherwise else system.out.println. So position of the data item is, or with the double quote I can write the data item found at position, the data item found at position. Okay, so output variable we have taken index. This. So here, when this part is method call, so when this will execute, the method definition will execute. This part will be execute. Okay. So what is array or ARR? I have initialized n representing the length of an array. The variable item value that we have taken, that is 60. So let my output variable is index. So already we have written one point. If data item is not present, then return -1. So that things I have written. If index double equals to -1, data item is not present. Otherwise, data item is present. The value of index is the output. So I will hit run. So based on the output statement, we will get the output. So you see the data item found at position 4. So this is linear search program. So give a response through chat. In which way I wrote the program. So I hope everybody got clarity how I wrote this program. Give a response through chat. Okay. Uttam, Shakti, Susri, Surjanarayan, Shobhna. I hope you have understood. Okay, so this is linear search. Then we will go to the next technique, that is binary search. But objective is one, to find the index value of a specific data item. That means in which index that specific data item is present. So but we will go to the next point, that is binary search. Binary search is also important, more important than linear search. So first of all, you remember when we are going to binary search. First of all, binary search work on a sorted array. Suppose an array is given, let data item is 10, 20, 30, 40, 50, 60, 70. So the data item in a sorted, zeroth index, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index. Suppose same way, suppose an array is given and a data item is given. Same, suppose 60, suppose. The data item is given, we have to find out the index value of that data item. The point number one, you remember, binary search works on sorted array. You remember the first point. Whatever the array is given, the array data items must be in sorted order. But in linear search, That type of case is not here. Then simply, very simple things. In binary search, only we need to get the mid value. Mid. Suppose, let this, I will suppose I will take this as a start. Let this is, I will take this as a end. Okay. So start plus end. First of all, this is 0. 0 plus 6 by 2. That is 3. So 3 is the mid value. Now, first I found 3 is the mid value. First of all, one variable, suppose we consider as start, one variable we consider as end, or low or high. It depends upon you, whatever you can give the name. So what I told, the concept is saying in binary search context, simply we will find the mid value only. Now, how I will find the mid value? Start plus end divided by 2. So start index is 0, end index is 6. So 0 plus 6 by 2, that is 3. Then we will check if that mid data item is our item, because our item I have taken 60. If there are 3 cases will arise here. If mid data item is 60, no. If mid data item will be 60, then the return mid index. That means 3 is the output. If mid position item is not 60, then we will compare. Mid is less than 60 or mid is greater than 60. We will compare. Now 40 is less than 60. If mid value is less than data item, then mid equals to mid plus 1. Now new mid equals to 4. What I told, if again I am repeating, if mid value is less than given data item, if mid value is less than given data item, then mid equals to mid plus 1. Again I will consider this is mid. If mid value is greater than data item, then I will consider end equals to mid minus 1. This position, that position I will consider as a new mid, end minus 1. Sorry, mid, end equals to mid minus 1. Okay, again I am repeating. If the mid value is less than data item, mid I will consider mid equals to mid plus 1. If mid value is greater than data item, then I will consider end equals to mid minus 1. Now you see 40 is less than 60, so mid equals to mid plus 1. Now this is our what? Sorry, this start equals to mid plus 1. If the mid value is greater than data item, then end equals to mid minus 1. So here 40 is less than 60, then start equals to mid plus 1. So start is equal to 4. Now start is 4, end is already 6. Now again we will find the mid. This concept is saying always we will find the mid value. Once we will know start index, end index, then I can find start plus end by 2. So first of all, 0 plus 6 by 2, 3. First mid I found, and first mid data item is 40, but my required data item is 60. The data item 60 present in which index, that we have to search. So here mid value 40 is less than 60. So as per the concept, if the mid value is less than 60, then start equals to mid plus 1. New start equals to, I will consider as mid plus 1, that is 4. Now new start is 4 and is 6. Again I will find mid, 4 plus 6 by 2. So this is 5. So again, after finding the mid, so we will check mid value is how much, 60. So if mid, new mid equals to our data item, if it true, then output is 5. If not, then same way, mid value is greater than data item or mid value is less than data item. If mid value is greater than data item, then end equals to mid minus 1. If mid that value is less than data item, then start equals to mid plus 1. So here we got, because 4 plus 6 by 2, that is 5. 5 that position data item is 60. So 60 double equals to 60. So this is true. So return mid. So output is 5. So this is the what concept of binary search. So first of all, binary search work on sorted array. Data items must be in sorted order. Second thing is mechanism is simply only we will get the mid value. So we will consider two variable. One is let start and one is end. Start plus end by 2, that is mid. So whatever the mid data item I will get, then I will compare mid double equals to data item. If it's okay, then return mid, that is the output. If mid is less than data item, then start equals to mid plus 1. If mid data item is greater than data item, then end equals to mid minus 1. So I hope everybody got clarity. Then I will write the program. Let us suppose this program I will write in a notepad. So very explicitly, suppose I will write, let class, let class name is binary search. Same way, in which way I wrote the linear search program, in same way I will write binary search program. One method I will define and that method I will call. So let I will define a method. Okay, so let my method name is binary search method. Don't confuse class name binary search B capital, but here B lowercase. This is different. And same things. So definitely I will take an array. Let my array name is ARR, and data item I will take. So int item. Suppose. Okay. So let I will consider two variable, start equals to 0 first, end equals to array ARR dot length minus 1. So first of all we will consider these things. So two variable already I have explained. So first I have to find the mid value, 0 plus last index by 2. So last index is how I will get length minus 1. So that's why in this way I presented two variable. I will took one is start and one is end. So let start is 0, end is array length minus 1. Array length already we have known. Array name dot length, then minus 1. Then I will continue a loop, while loop. So I can write while start is less than equals to end. Then we will consider, so by taking an example, so this is 0 is the start, end is 6, while 0 is less than equals to 6. So within this we can move. So while, that's why I wrote while start is less than equals to end. While start is less than equals to end. So first of all I will find mid. Let one variable mid, suppose I will take int mid equals to, okay, so I can write start plus end divided by 2. So then whatever I will find the mid, same whatever I discussed, if ARR of mid double equals to item. So what I told, first I found 0 plus 6 by 2, that is 3. 3 data item is 40. If this 40 double equals to 60, then return 3, return mid. So if not, then we will go to next two cases, greater than data item or less than data item. The same things I will write if this, okay, one statement, no, okay, write the curly bracket, it will be better. Return mid, this. Then else I can write again if ARR of mid, okay, is less than item. Currently I told, then what I will write, start equals to mid plus 1, whatever we discussed. Otherwise else, okay, so end equals to mid minus 1, this part. Then so while loop I will complete, after loop completion, suppose if that item is not present, so if you reach here, if suppose element is not present, then I can write return minus 1. Okay, so now this, suppose I will end this class. First of all, what I did, very simple, whatever we discussed, that discussion I presented in the form of coding. So simply one class I took, so this is binary search. Then one method I defined, let the method name is binary search. An array I have taken, data item I have taken, number of input, that is number of arguments. Then as per the mechanism, so start and two variable we have to take, so I have taken. So start is 0, end is length minus 1. So while this simply mid value, just I will find. So if the mid double equals to item, then return mid. If not, if less than that item, then start is equal to mid plus 1. Again new start, then end, start plus end by 2. Again it will find, we will find the mid. Else this, otherwise return minus 1. Then in this way while loop I had completed. This is method I completed. Then I will go to main method, public static void main string args. This, okay. So here a method I have defined, but in Java programming, in later on again I will explain when a method is invoking by the object. So class name is what? My class name is binary search. So already little bit idea that we have how to create an object. Class name binary search object name equals to new class name binary search. So an object I declared. Let obj is which type of object? Binary search type of object. Binary search is a built-in class name. So object is containing class property. Object is a memory. Simply. So this object obj is representing binary search class property. So whatever within a curly bracket begin and end, anything is present, that is the class property. So now, so here I will represent explicitly. So array I will represent. So int arr equals to, so which data item we have taken? 10, 20, 30, 40, 60, 70. Let 10, 20, 30, 40, 50, 60, 70. Okay. Then we will find the length n equals to arr dot length. Okay. Then data item int item equals to let 60. Okay. Then I will call obj dot method name. I will call simply let my method name is binary search. Okay. So method call and method definition signature must be same. So here two arguments I have taken array item. So that two argument we have to taken arr comma item. You remember method call. This is method call. This is method call. So method in Java programming, this method we have not defined as static. If I will define a static, then there is no need to create an object. So in varieties of first linear search program, I presented as method as static method. But in binary search, I presented as normal method definition. So you remember in Java programming, when a method you are defining a method definition representing a task. So that method when I will call by an object, then that method definition will execute. So let it, so this line will execute, suppose definition will execute, so output variable I will take. So let output variable is int result. Same way I can write if result equals to -1, then data item is not present. Then I can write system.out.println. So I can write data item not so present in array. Okay, same way I can write else system.out.println. So what I will write, data item is present at data item is present at position. Okay, there is a space, suppose I will give. So position output variable is result. This else part completed, then uh, main method completed, then class completed. Okay, so this is my program. This is my binary search program, and I will save this program. So go to E drive Java programs folder and class name dot Java. So class name binary search class name dot Java, and I will do all files. Then I will save. So I will go to command prompt, go to E drive, go to Java programs folder, Java C binary search dot Java. Okay, then Java space class name binary search. You see the output is the data item is present at position 5. So you see, so 60 position is 5. The data item position is 5. So this is the code and this is the output. So very simple. What we did, simply one method I defined, then that method I called or I invoked by the object. Okay, and as per the mechanism, first of all, the concept behind this algorithm you have to know first. So overall, I am repeating, binary search works on sorted array. Then mechanism is simply we will find the mid value. So how I will get mid value? Start plus end by 2. So two variables, let we will consider one is start and one is end. So let start value is 0, end value is length minus 1. Then mid I will find start plus end by 2. After finding the mid data item, three cases arising in our picture. So whatever the data item we have taken, so that data item double equals to mid value, or whatever the mid I got, then the mid data item double equals to item, or mid value is less than data item, or mid value is greater than data item. So three cases. So if mid equals to item, then return mid. If mid is less than data item, then start equals to mid plus 1. Again we will find this is start, then end, then start plus end by 2. Again I will find the mid. Similarly, if the mid value is greater than data item, then end equals to end equals to mid minus 1. Then once end I will get mid minus 1, start is already given. Then again I will find mid, start plus end by 2. So always in one line we got mid, then which case I will compare, then again mid, finding the mid. Again we will find the mid value, start plus end by 2. So always mid value we will get. Okay, so this is all about binary search. So I hope everybody got clarity, give a response. So this is all about today's session. So I hope everybody got clarity, give a response. So through chat, give a response. Shobhana, Sritam, Somyasri, Susri, Madhumita, okay. Subhendu, okay. So binary search is very important. So this is the data structure. For the interview point of view, this point is also important. I will suggest do the practice because hands-on is requiring. Okay, Rupali, Susri, Uttam, Bhavani, okay. Sujanaren, okay. So do the practice. So this is all about today's session. Linear search and binary search. Next class we will cover sorting. Similarly, some sorting techniques that we will cover: bubble sort, selection sort, insertion sort, merge sort, heap sort. There are so many sorting techniques. So we will use some techniques to sort an array. Sorting and searching, two basic operations that we can perform on array. Okay. So thank you to all of you.